shall be looking at what we call a double integration. Now, if I have a function like this, if I have 0, a function starting from 0 to x being unknown, and the other one is also starting from -1 to 3. If the entire function, the actual function is x, y, check that for this order, look at the order very well. This is where we have the order. If I have dx, dy as this being the order, you see, this is what you call the inside. This is inside, and then this is outside. Now, with this, we also say this is outside, and then this is also inside. Look at it carefully. Look at it carefully. Look at the inside and then the outside. Good. Very good. Good. Now, from there, we say if that is the inside and that is the outside, looking at the order being the x inside and the y outside, what you say is that now we are looking at the inside, we are working from the inside function. So if I have to graph this thing, this is how it will be. So then, this is how it will be. If I have my x, then because the outside is equal to this one, everything is equal to y. Because for the outside, it's like this. The whole of this outside is equal to y. It's equal to y. So x is equal to y, and then my 0 is equal to y. So for the inside, I have my -1 will be equal to x. Get it? Good. And my, what do you call it? My 3 will be equal to what? X. Good. Now from here, I have to graph this thing, the whole of this thing. Now, if I'm graphing, this is how it will be. I have my graph like this. And then I have to plot this one. For this line, x is equal to y. It will be like this. X is equal to y. Yeah. So that if x is equal to 1, y is equal to 1. If x is equal to 2, y is equal to 2. So that is how my graph will be. Now, I have to also plot a graph. Y is equal to 0. Y is equal to 0. Now, for y is equal to 0, if y is equal to 0, then we are finding values on the x-axis. That means we are finding values on the x-axis. So this is x is equal to y is equal to 0. Good. Now, I'm looking at the inside part. Now, I have to plot my x is equal to 3. X is equal to 3. So, x is equal to 3. This is my x-axis. So, let's say here is 3. I have my x is equal to 3. Good. So, x is equal to 3. Now, I have to plot my x equal to -1. If I have my -1 here, -1, I'll draw my x equal to -1 like that. That is my line, x equal to -1, and then the line x is equal to 3. So we're actually looking at these regions. You see, the entire function has become a triangle like that. Yeah. Look at it clearly. Look at it carefully. That is how the graph will be. Good. Good. Now, let me come back to solve the entire function so that we will see the value that we will get for the whole area of this part and then that one. So this is what we have to do. Now good. Wow. Now, when I look at the dx and then the dy, you see for x and y, now looking at this inside, I will take this x as the function that I have to work with respect to the y. So the y will become a constant for me now that the y is outside. So the y will be a constant in our solution, and then the x will be the one that we are actually going to work on. So for this one, I'll have my outside solution. So I have my outside appearing like that, x and 0, and then I have my inside like this, minus 1 and then 3. So have being with x, yeah, being with x, all with y dy. Hello?
Hi.
Good. So this is what I have to do. Now for this one, I will just integrate the x. So I have this, my -1, and then 3, sorry. So I have my integration of x, and I have my 3, -1 like that. So the integration of x becomes s squared over 2. So I have my 3, -1. Now when I continue, you see that I'll have my 3 with the power 2 all over 2 minus -1 square divided by 2. So I'll get my 9 on 2 minus +1 on 2. So here I have my 9 minus 1 all on 2, which is equal to 8 on 2, and I have my 4. So I have 4. Yeah, so I have 4. Good. Now that I've worked the first part, so it will be like this.